Hello students, welcome again to the new segment. In this segment, we will be looking at some more additional information regarding the naive Bayes classifier. So the first thing we want to emphasize is that if our data set is categorical, so still the naive Bayes classifier can build a model, right? So let's have an example with the categorical data. Remember, we have downloaded the flag dataset and we have removed all the numerical attributes from there. So it is, and then we saved it in one of our last lecture, so that we have still that data. So let's have a look at some of the instances of that data. So all of this data has categorical attributes. So now in order to learn the naive Bayesian classifier based on this data, we can pass the table T to it and mention that our response variable name is, let's say, green1 in this case. And it's always good practice to assign it to some variable. So when we press enter, it is going to build a model for us. Now, one of the interesting things that I want to mention here is that the distribution names. Right, so previously with the numeric data, it was using a normal distribution, but now in this case, it is going to use multivariate multinomial distribution. And this makes sense because with the categorical attribute, it cannot actually compute the mean and standard deviation. So that's why the other distributions may not work in this case. So this distribution is going to work. One more thing that we want to specify is that if our data contains numerical attribute as well as categorical attribute, and if we want to run a naive Bayesian classifier, so how to do that? Remember, we have another data set which is 2.csv, and it contains a mixture of categorical as well as numerical attributes. So let's do some example with that, right? So variable 1 contains a numerical attribute, and these three are categorical attributes. So now if you want to build a model based on this data, right? Fit C and B. So we can pass and we can mention that our variable is green in this case, green1. So what will happen now is that it is going to return an error message, right? And the error message is a normal distribution cannot fit for the combination of class Blake and predictor variable 1. So it means that in general, it is not going to build a model for us when our data contains both numerical as well as categorical attributes. So how to do this? Well, we have in the last lecture mentioned a property called distribution. So now in this case, we need to mention the distributions that we are going to follow. So if we mention exactly the distributions, that is that our variable 1 is following a certain distribution, variable 2 is following certain other distribution. So in that case, we can build a model. For example, we can mention here that variable 1, since it is a numerical attribute, so we may mention that please follow a kernel distribution for that. For the second variable, which is not a numerical, so we can mention that please follow a multivariate multinomial distribution. And for the third one also, we mentioned that multivariate multinomial distribution. So now this is a way around of learning a naive Bayesian classifier based on a mixed type of data. That is numerical data as well as categorical data. So when we press enter, it is now going to build a model for us. And if you look at some of the properties, this is the kernel distribution, and then for the second and third variable, it is following multivariate multinomial distribution. Right. One final thing that we want to mention is regarding this variable, or this property, that is categorical levels. So this property is actually containing the information that if a predictor is following a multivariate multinomial distribution, then it contains its indices of its different values, right? So we can mention that. So now, since we know that the first attribute, it is not following the multivariate multinomial distribution, so that's why it is empty. But however, for the second attribute and for the third attribute, since they are following the multivariate multinomial distributions, So now in that case, it is telling us its different indices of its different values. So if you have a look, for instance, for the second variable, all the distinct values for the second column, which corresponds to second variable, and we can use the built-in MATLAB function unique, and it will tell us all the unique values across the second attribute. So for the second attribute, we have 8 different values, 1, 2, 3, 4, 5, 6, 7, and 8. So now if we access m.categorical levels, and if we access the second element of that, it will contain indices from 1 to 8. So it means all those 8 values have been used in order to consider its multivariate normal distribution. Similarly, if we consider its third value, it is containing 7 distinct values for the attribute for the third variable. And if we have a look, we can verify it from here. The third variable, it contains 1, 2, 3, 4, 5, 6, and 7. So 7 different values. So this is also very useful property of the naive Bayesian classification model. So there were a few more notes. Hope you're enjoying the course. See you in the next segment.